Hi everybody. This is now my third time making this video. First time something happened with the picture and it got all screwed up. And the second time my audio did not work. So welcome to my third lesson on this. Hopefully if you're watching this, that means it worked. So today we're going to be reviewing slope and rate of change. And hopefully in your investigation, you guys were able to recognize the difference between slope and rate of change. And we are going to be getting into that right now. Okay, just to kind of go over the key idea, we're always going to review the key idea, which is linear equations. A linear equation makes a line, and the points on the line are the solutions. Remember, you have all kinds of points on the line. Every point on the line fits into the equation y equals x plus 1, where I plug in x and y, and they end up equaling each other. Here I have my x and y chart. This is my independent variable. This is my dependent variable because my y always depends on what I plug in for x. I never choose my y, I choose my x, and my y depends on that. And so there I can plug in, for example, if I want to use this point right here, -3, -2. If I plug this into the equation, this is x, this is y, I get -2 equaling -3 plus 1, which gives me -2 equaling -2. So I have my linear equations. Hopefully you guys remember this. Looking back at the summative, you guys read through and you guys found how to do the slope equation. And so hopefully this was a little bit helpful. If it's not, we're going to go through it more right now, but this is what you did in the summative. So by this point, you should know that slope is just a synonym for rate of change. These are the exact same thing. Slope and rate of change are the exact same thing. You found the rate of change in the summative, and you should have realized, oh my gosh, that is your slope. So what is another definition for slope besides rate of change? We can also define it as a few other things. Slope is the steepness of a line. That's what slope actually means. That's its true definition. Okay, is how steep a line is. The steepness of a line is if I had a line and it was going like this is a hill. Okay, that's a fairly steep hill. It would be difficult to walk up. This is an even steeper hill. That would be quite difficult to walk up. This is not very, actually, let's bring it down even more. That would be quite fairly easy to walk up. If we look at a downhill, that wouldn't be too bad, but it would get fast quickly. If I was going downhill like this, that's very steep. I definitely wouldn't want to fall down something like that. And we can have, that's actually still kind of steep, but we can have a not so steep downhill as well. And that's the steepness of a line. Another word that can be used, again, is called the gradient. So there's several words. Gradient also means slope. When I lived in California, they would tell you always the grade or the gradient of the hill that you were about to drive up. Because if you were about to drive up a hill that looked like that, that would not be easy for your car. It's not easy to go up a hill that steep. So they would always let you know. So steepness, gradient, slope, those are all the same thing. All right. Now, let's look at, let me add another page here because I'm going to run out of room. Another thing that slope has is it also has its own variable. The math world, and I don't know where the math world came up with this, likes to say that slope is m. Maybe because it looks like two hills and steepness, I'm not really sure. But m equals slope. So a lot of times in equations, you're going to see m equals, and that's going to be your slope. All right? So if you ever see m, you also know that that means slope. Okay, and let's keep going here. We have our equation, slope equals y2 minus y1. You guys learned that here. And we'll go through that in a second, over x2 minus x1. So you're probably not going to see the word slope written anymore. You're probably going to see m equals y2 minus y1 over x2 minus x1. Now, we're going to talk about where this comes from. This is super important to put your y in the top and your x in the bottom. This comes from your dependent and independent variable. Y is always your dependent variable, and x is always your independent variable. That is why your y has to go on top. When we looked at our summative, and I'm going to go back to that a few times because that was the whole reason we did the summative, was to investigate slope. We had the point 3, 118.5. 3 was our weeks, and 118.5 was our kilograms. And you told me, when we went through this, if we were going to make it into a rate of change, a fraction, that there's a certain way that the labels make more sense. So I could either say weeks per kilogram, but that doesn't make sense. That would be x over y. That would be what a lot of people do. They put x over y. But weeks per kilogram doesn't make sense. It makes more sense to say kilograms per week. Again, because this is my y, kilograms is my y value, and week is my x value. This is why y needs to go on top. The independent variable should always be on the bottom. Independent should always be on the bottom. The dependent variable should always be on the top. The dependent variable should always be on the top. So now when we also had, again, we're going to go back to the summative. When we had the 3, 118.5 and 4, 118, when we wanted to find kilograms per week, we looked at our y's. From 3 to 4, we looked at how much it changed by. To find the change or the difference, we subtract. So we said 118.5 minus 118, which was 0.5, or it went down. Some of you said down 0.5. Okay, which you should have said down 0.5. And that's actually 118 minus 118.5. That gives you negative 0.5. Okay? Then we looked at our change, our difference between 3 to 4. Okay, and that was 1. And that is saying 4 minus 3 is our difference of 1. Had you done it the opposite way, because you get negative 0.5 over 1. Had you done it the opposite way and said 118.5 minus 118, you'd get 0.5. But then, if you went from this one to this one, then you'd have to do 3 minus 4, which is negative 1, which would give you 0.5 over negative 1, which we know we pull that negative to the top anyways, and that gives you negative 0.5 over 1. So again, it's so important that you do not mix this up. The y goes on the top. I'm hoping that I'm drilling that into your brain enough so that you know this, because what happens when you memorize an equation, you don't always have it there, or you know it for the time being, or you don't know where it comes from. But in this case, yes, you're going to need to memorize the equation, but my hope is that you're able to see it and you're able to know it because you understand where it comes from. You know what it is. I've been pushing this in your head since day one. So we can say that slope is y2 minus y1 over x2 minus x1. We can call it the change in y over the change in x. We can call it the change in your dependent variable, which some of you might even say in your total. Remember I told you that this line can be called per your change in your independent variable, your number of. So your total per number of, okay? Which we can even write that right there. This is always written as a rate or a unit rate even. A unit rate is just when your number on the bottom is 1. So it's per 1 hour, per 1 day, whatever. A fraction. And there's a Greek letter called delta. This Greek letter means delta. And what it actually means is change in. So a lot of mathematicians and scientists and physics scientists will use this symbol. Instead of saying the change in y over change in x, they'll say delta y over delta x to have it as a shorthand equaling your m, your slope, because they think that's, not they think, it just is. It's a lot easier to write it in that way. It really is a lot easier just to put delta y over delta x, where I know this delta means the change in y over the change in x. So hopefully you understand what is slope, what is rate of change, and you really can fully grasp it. You really can understand it, and you recognize that the y is always on the top and the x is always on the bottom. Taking a look at one more example. Let's say I have 3 hours and $15, 6 hours and $30, okay? This could be talking about babysitting for your brothers or sisters, and your parents are like, I'll give you money. And so if you work 3 hours, you get $15. If you work 6 hours, you get $30. I know X is the number of hours. This is what we've been doing the whole time. This is what you're familiar with. I know Y equals my total money. So I know a point tells me my total hours per my number of hours per my total money. So if I want to find out my rate of change, my slope, how much I'm making per hour constantly, which is my rate of change, and we know that that means slope. It's the exact same thing. They're synonyms. I can look and I can see. Am I going to be talking about how many hours per dollar I have? No, you're not going to talk about hours per dollar. You're going to talk about dollars per hour. And which one represents your dollars? 15 and 30. That is your Y, okay? So if we want to find our dollars per hour, it's going to be Y over X. Again, guys, I'm telling you this and pushing you this because most people will make mistakes here. It happens all the time. I want to know, well, what is my change between 15 and 30? My change between 15 and 30, maybe I should make this a little bit smaller. Why isn't that working? That's okay. So is going to be $15. It changes by $15 going from 15 to 6 and going from 3 to 6 in 3 hours. Now that's not fully simplified. I can simplify by dividing by 3 and I get $5 per 1 hour. This is my slope. This is my M. This is my rate of change. Okay? That, again, is just another one of my million examples of going through and showing you, you have been doing this since the beginning of the school year. You just didn't know it. Okay, another way that you could do it with the slope equation is by saying, oh, well, this is x and y, and so this was your x1, y1, x2, y2, because this was my first coordinate, my first one, and this was my second coordinate. Okay, so we found the change in our x's. So we said $30 y2 minus y1, which was 15. And then we said yx2, our 6, minus our x1, which was 3. And that gave us 15 over 3. So again, I'm just trying to drill it into your head that you guys have done this. You know how to do it, and you've done it. All right? Even if you would have done it the opposite way and said 15, I'm sorry, I keep going back to this. 15 minus 30 over 3 minus 6, you would have gotten negative 15 and negative 3. And a negative divided by a negative is a positive. You would always keep it as that positive, which still is going to give you 5 over 1. So now we're going to look at, there are 4 types of slope. Okay, there's 4 types of slope, and these 4 types of slope are the only types of slope that exist. Because when we're talking about a straight line, there are only so many directions that a line can face. Okay, and so our first direction that we're going to talk about looks like this. And this, ladies and gentlemen, is called, if you would look at this, you realize it's going uphill. Because we are looking at it going from left to right, just like if we're reading. If I placed a person on here, Mr. Slope Guy, he would be going uphill. Okay, he'd be going up in elevation. So we call this an increasing slope. If a person in marketing was looking at how well a product is doing and they saw something like this, they'd be like, oh my gosh, we're gaining money, it's increasing. And so this is either going up and to the right or down and to the left. Up and to the right or down and to the left. Okay, our next type of slope is when a line is facing down. Now, notice like I said, your line, so if we're going down, facing down like this, the steepness can change. It's going to go anywhere from being, there's horizontal, anywhere between there and vertical is going to be a down line. All right? And our slope person, if they were on here, they would be going skiing. Because they'd be going down a hill and fast. Smile on their face. Yay! I don't know if that looks like a smile or scared. But they're going downhill. We didn't put a smiling. There we go. And this, if any person was looking and they're saying, this is a graph of our sales right now, any person would look at that and go, oh my gosh, that's decreasing. This is a decreasing slope. And it's either going down and to the right, because remember, we go up and down first because that's with our Y. Y is always first. Or it's going up and to the left. Our third type are our two flat lines. One is going to be our horizontal flat line. Okay, if I have my horizontal line and I had a person on there, our slope guy, he would just be right there, not walking up or downhill. He's just straight line, no up or down. Okay, and another picture we can draw is a beautiful sun set. When you go and you watch the sunset, you're watching the sunset on the horizon. Okay? So this is just going side to side. No up or down. Okay? Because we're not actually talking about the movement of the sun. We're talking about the horizon. All right? And then the last line that we can have is one that goes up or down. You can think about it like a clock too. There's only so many directions that our clock could be. This is between 12 and 6. This is between 3 and 9. And then these are any numbers in between. This could be this positive one. It could be 1 and 6. Or 1 and 7. Blah, blah, blah. Whatever. Okay? I'm sorry. I talked a lot yesterday, so. This right here, the only really thing I can think of is, I guess, an elevator moves up and down, but it's more fun to talk about a UFO. UFOs move up and down. And there's our slope guy, and he's like, oh my God, I'm so happy. Okay, so this is called a vertical. A vertical slope, because it only goes up and down. It does not go side to side. All right, so these are our 4 types of slope. There's no other line in the possible world that could exist except for these 4 types of lines. Like I said, these 2 right here, though, can have different angles, different degrees, different steepnesses, but there are only, like I've shown you, these are the only directions a line can go, so these are the only existing slopes. So we know what we've gotten to the point now when we're talking about math and we're talking about up. We know that the best way to represent up is to use a plus. When we represent down, we use a negative. Just like when we were doing our geometry and our translations. When we move to the left, it's subtraction. Move to the right, it's addition. If I wanted to move to the right 3, I would add 3 to x. If I wanted to move down 4, I would subtract from y. So we know when we want to move up, when we're looking at a remote control or anything like that, up is plus, down is minus, left is minus, right is plus. So we're going to look at our 4 slopes. And let's start right here. Let's look at our increasing slope. Okay, our increasing slope is either going up and to the right, up and to the right. And actually, we'll continue. It's either going up and to the right, or it's going down and to the left. Now, when we're talking with up or down deals with our y, and right and left deals with my x. So again, this is going to be y over x. Again, another reason why y comes first and not x. So when I'm doing this, I know up is plus over right is plus, or we have down is minus over down is left. So I can say a positive divided by a positive is positive. A negative divided by a negative is a positive. So these both equal positive. What this means is an increasing slope is also called a positive slope. And you can kind of assume that. It looks like it's a positive thing because it's going in the positive direction, towards the positive numbers. We also have our decreasing slope. Well, I'm going to use a different color for that. Let's use this. Our decreasing slope. Our decreasing slope goes either down and to the right, or up and to the left. So I can see that down is negative, right is positive, or up is positive, left is negative. A negative divided by a positive or a positive divided by a negative is both negative. So we can see that a decreasing slope has a negative slope. Our m is going to be negative. M is going to be negative. Here, our m is going to be positive, whatever number we find. Next, we have, and actually, let's look at this for a second before I move on. When you guys did your summative, you had your graphs and you said these were your weeks and this was your total weight. And your graph probably looked something like this. Okay? And you told me that he lost 0.5 kilograms per 1 week. That means your m was negative 0.5 over 1, or the same as just negative 0.5. Your m, your slope, was negative. Your graph had a decreasing slope. It was a negative slope. So now let's look at our horizontal. Our horizontal is like the horizon. Okay? Horizontal is like the horizon. And this doesn't go up or down. So it has 0 up or down because it doesn't go up or down, but it goes to the right or to the right. So you either have no up or down, but to the right, or you have 0 up or down, but to the left. Well, that equals 0. 0 divided by anything is 0. 0 divided by a positive or 0 divided by a negative is 0. What this means is that it is a 0 slope. Okay? Now, I've explained this a million times and I'll explain it again. If I have 3 friends and I have 0 pieces of candy. So I have 0 pieces of candy and I want to divide it amongst my 3 friends. How many pieces of candy does each person get? They get 0 because I don't have candy. And if I'm handing out 0, they have 0. They have no candy. Each person has 0 pieces of candy. So that's where it's 0. This is a 0 slope. You can also think of it as elevation. Here, they're going up in elevation. They're increasing positive elevation. Here, they're going down in elevation, decreasing negative. Here, he's not going up or down. He's at 0. The horizon is 0. The sun sets at sea level, which is 0. Now, this doesn't happen super often, but it sometimes does happen. And the reason it's 0 is, take a look. If I have a graph, and this is total money, and this is weeks, okay? What could happen is 1, 2, 3, 4, and this could be 5, 10, whatever. Let's say the first week I earn $5 and I have $5. But after that, my business crashes and nobody buys anything else. Okay? I'm earning $0 per week. I started at 5. I had 5 now, but I'm not gaining anymore. So this means I have a slope of 0. My rate of change is 0. I'm not going up. Oops. I didn't mean to. I'm not going up or down any. I'm just remaining there. It's not increasing or decreasing by anything. Okay? And then last but not least, we have our vertical line, which even more so is less likely to happen, but it's still, we need to know. Okay, this one goes either up or down, but it can't go right and left. So it goes up, but 0 right or left, or it can go down, or 0 right or left. So that's going to be plus over 0 or minus over 0. And this, ladies and gentlemen, we call undefined, because you cannot divide by 0. It is impossible to divide by 0. I will show you my example again. Now this time, though, I have 3 pieces of candy, and I want to divide it amongst my 0 friends. So I have 3 and I want to divide it amongst my 0 friends. Well, how many pieces of candy does each friend get? It's not 0, because that would mean the friends are there. The friends don't exist. If they don't exist, I can't give any of them candy. Even if I have 0 pieces of candy and 3 friends, I can still say how much candy does each friend have, because the friends exist. But I have 3 pieces of candy and no friends. I can't say how much does each friend have, because the friends aren't there. They don't exist. All right? And so this is called undefined. Undefined is the same as don't exist. We call this undefined slope. The slope doesn't exist. And I'm going to give you an example right now of what I mean by the slope doesn't exist. If I have a graph, and if this is weeks, and this is dollars, and I have the same graph as before, 5, 10, 15. Okay, so an undefined slope would look like, okay, after 1 week, whoops, that's not what I wanted to do. After 1 week, I have $5. And then this is what the undefined graph looks like. It's a vertical line. This would say, what this is saying is after 1 week, it keeps going up. $5, $10, $15, $20, $30. And that's fine. But if that's saying that's only happening in 1 week. Even if the money would go up and up and up, eventually time would pass and it'd have to get to 2 weeks. Even if it was up to $50,000, $100,000. I know that's not a number, but whatever. Even if I got all the way up there, at least time would lapse and go to my second week. This is saying basically that time stops. You're not going to your second second week, but you're just continuing increasing money. That can't exist. Time cannot stop. You can't just constantly be increasing money and just stay frozen in time. In the real world, you can't do that. So it doesn't exist. That's why this slope doesn't exist, because you can't constantly be increasing and not moving over in your time.